Hello, everyone, and welcome to the broadcast. Apparently, yeah, okay, it's working. It's working. Just gotta make sure. We're back. We're gonna be working on our code project today. We're gonna be doing a bit of an extra long stream. One, to make up some ground. We've missed a bunch of broadcasts recently. So I want to make sure that we're still giving the folks that want to see it a chance to see our progress. I do see that Zane has joined us already. Hello, Zane. Now, big thing that let's check in with the kitties first. Hey there, Skylar. We do have Ember visible. We have Mason and Sky. Sammy is being an absolute nuisance. She is sitting on my lap right now, but she's being really bitey. Hopefully she will make less of a habit of this over the course of the broadcast. Oh, let's get in there. Okay. You mentioned that. Okay, so this is not our active project. This is a test project to show you one of the things that we've been working on. And it is visible right here, this tester.cs. This if, let's see. I can't zoom that part in, so trust me, there's tester.cs here. That is the file extension for a C# segment there. So we are going to just run that. Again, real tiny. Every one of these black dots is an entity like we're using in our main project. But we are hitting 17,000 objects, 20,000 objects, let's say 25,000 objects, and we start to slow down. At about 40,000, we start to dip below 30 frames per second. 50,000, we're still sitting at 20 frames per second, which is pretty good. Hey there, kitty. So let's switch back here. So I did some project prep on it so that we've got the C# project ready. But one of the things we have to do is decide how we're going to approach this. And just to make sure, hello everyone joining us. So I created this just so that we have a script here. Let's open it up. No, I'm not going to install that because I don't want to have to sign into my Microsoft account. Thank you. Just maximize that. So we can create scripts here. One of the tricky elements of doing this, though, is the translation layer. Because if I have to do things like pass an array back and forth, hey Zell, over there on the Twitch side, we do have, let's say I take an array of objects and I pass it across, an array of integers. On the Godot side, that whole array is an object and it is passed by reference. But if I pass it over to the C# side, it's not the same object anymore. It's just a data structure. So if I mess with that data structure, it doesn't work the same. It doesn't edit the values back on the other side. If I pass in an array of integers as an extra bit of fun, so I've just got a big line of numbers here, a big group of numbers, If I pass that across to the C# side and then pass it back, I don't get a Godot array of integers. I get a packed integer array object, which for Godot, it's a very memory optimized array, but it is a fundamentally different type. It does not translate over the same way. It is a different thing. And to convert it back, you have to make some adjustments to account for the fact that you're crossing the line. So that's part of what we're going to be doing. At a bare minimum, just delete that little guy right there. Don't need him. At a bare minimum, we need this entity manager cut over. One of the things I'm not sure is how these objects will translate. I think they will based on some reading. One of the fun things is we don't need to worry about putting it in a thread. What I was showing you in that sample project, not in a special thread. No special processing for that. That was in the default physics thread. Even if we add other things that increase the burden on that, 10,000 active objects is pretty good. It's pretty good. We have to get far into kind of our calamity case for that to be an issue. So, what we'll start to do is we're going to make a C# script to start down the road of replacing this. We're going to make one that is in parallel to it. So we've got this entity manager here. We do need to rip out all of these pool objects soon as well. They are vestigial, and they are also kind of an error surface if I don't have everything lined up right. They're currently only useful for ensuring that a entity is cleaned up correctly. C# script, this is going to be entity manager. So there'll be a little bit of song and dance as we're doing this because I need to hop back and forth to look at this code, jump over to the C# side, and look at that. So what does this extend? Node. Okay. Just make sure extends node. Oh, no. Just delete temp.cs. Yeah, we'll have it ask us just in case. Where did we put that? Globals. So entity manager type extends node. Hooray. We are going to name it something different. Oh, no. Okay. Just going to bite the bullet on that. So you see how I've got this kind of naming convention here. If I'm going to use a class that is in C#, there is the possibility that I need to load it directly. And if I load the script, if the class name does not match the file name, it won't recognize it properly. That's a hassle, but frankly, I'm not really married to the naming convention for the files. It will bother me over time, but we'll get over it for now. Okay, we're going to want that kind of thing here. Even if I don't have to, I'm going to be putting semicolons after every line. There might be cases where I'll mess that up, but C# is a... C# requires a line terminator. Godot does not, because Godot it's kind of line based. It's indentation based, that kind of thing. I don't like that. It's another one of those places where it's kind of floaty as to what goes where when the indentation is a little off. So we won't be using the increment here. I do want to still keep the max delta, actually. So what that says is, what this means is, as far as entities in the world are concerned, if the system starts to slow down a great deal, a delta cannot be slower than this. So the world will essentially slow down if everything starts lagging too much. One of the kitties is yowling. We won't need that. We won't need that. Need you or you. Might end up having some mutex in there just to be sure, but there shouldn't really be an impact on that front. We'll see. So this is where things get a little tricky, is we're gonna have to come up with a way to get these classes in. Because the entity manager needs to store them. Which to me implies that we're gonna have to port over most of the infrastructure. Most of the things that we're ultimately going to be dealing with in the entity manager, so movement, all of that stuff, I think we're going to need to have over here, since we're going to be doing most of the interaction here. And that could daisy chain into other stuff. Because these files don't know what the Godot resources are. We might be able to get that, though. I thought we could get that. 1 second. Looking. There was a marker for this. Thought I saw something for it. Just finding it, you know? So what we're thinking on here is how to get. Hey there, Sniper. Good to see you again. We're thinking, and I'm looking up how we can get the C# and similar classes, well, the GD script classes, translated over, and I'm thinking we might end up dealing with a whole lot more of them as far as translating it over. Nope. Ooblik. Godot. So these are all the types that Godot has that can be used in C#. But the question becomes, what do you do? Nothing that I understand for this. So we've got to get our Godot objects over here, or we've got to parse them down into the bare minimum concept here. Because one thing we could do is have the entity manager be the thing that literally creates the entirety of the entity. With the exception of GUI elements, we just need to be able to get limited information, just limited information. So like inventory stuff needs an icon. That kind of thing. I would like to avoid having to recreate the entirety of an entity object, especially if the object on the Godot side isn't going to be hard typed on the C# side. So what do we do? We can get nodes from in here, and that will get references to things that are children of this node. How do we convert that into an object that we can use? So I'm thinking we are actually just going to need to because I don't have any indication of how to load this stuff over without it being a node. Seeing if we can do anything here. One of the things that we're going to be doing for this is that we're going to be relying on the signal logic as much as possible when we deal with this stuff. So we don't want to have to pass objects back and forth any more than necessary. How do we get this fully operating? Let's start with just getting... We're just going to prep stuff for now. Syntax there, yeah. So any of these functions that exist in Godot on a node, we can still use. So it inherits node, we have things like ready. Oh, how do we do this in this one? So forgive me, I'm going to be moving much slower on this because I'm less familiar with C# nowadays than I am with GD script now. It's gonna be a day like that. It really is. little early, but I'm gonna step away real quick. It'll give me an give me an opportunity to try to think a little bit on it. Okay, we're back. Oh boy, oh boy. Just doing some quick reading. Start off. Reading. Reading. A lot of this is stream of consciousness and learning new stuff, folks. If you have questions or just want to chat, feel free. Happy to pause and talk with you. Okay, this might be viable. So if we could try to instantiate the object, but what do we call it? Becomes the issue. Like, how do we can interact with an object. I know, Tess. I'm reading documentation right now. Generally, I try not to just put web pages on the screen. Yeah, I don't like going that route. Okay, so when you're dealing across the border with classes and similar, you need to reference them as essentially outside objects. So if it's C#, then I'm going to load that script and then instantiate it or similar. I don't know. Let's see here. Oh. Well, show you what we're looking at here. This is as resource. We can load it, and then we can new it. In a similar vein, let's look at our cross language here. So C# script is loaded same way, and then we instantiate it. The problem being is we aren't dealing with an actual script file. We're not trying to create it over here. We're trying to interact with it. Okay, Godot object. This is not great. This is really not great, but this is how we would have to interact with it if entity exists on the Godot side. I don't think I want it to, because we're going to be doing the most footwork with it on the C# side. So I think we're going to have to make a new entity that is a C# side object, because then we interact with it more. The more crude interaction happens on the Godot side. which I think I'm kind of fine with since we're only going to be using limited objects. For the most part, we're just going to be reaching into it and saying, hey, react to this event, or let me access this this method here. So I can get in set fields if I know their exact name. On the Godot side, a little easier than I can mess with Godot objects on the C# side. It's not perfect, but I think that's where we need to be. Okay. Which means, and this is still bothering me, hey Tess, do you remember how to, or can you let me know, how do I prime a an array so that it's not going to pitch a fit when I append to it? Do I even need to? So you definitely need to do stuff like this in the GD script. Oh, that's right. You would use like a list. That's right. Okay, so for our testing version here, we want to just display some stuff. We need to get it up and running. So list is really good at iterating over it. We're going to be adding or removing from it very frequently. So hash that would be better for a lot of addition removal from it, wouldn't it? So I don't really need them to be numbered. I just need to be able to iterate and remove them or add them. Hey, Sherbet. Hey, bud. Ow, 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 painful. Pointy toes. Okay, let's see here. Is that new? Hey, John. Welcome. Physics process. Load delta. Well, good to have you back. There we go. There we go. Yeah, the more I'm thinking on this, the more of this code is going to end up going over to the C# side. Because we're going to be able to do, I think, a lot more. We're going to be able to act in a much more controlled fashion if we stick to one, you know? No. I pet the cats frequently. Sammy and Ember very commonly come over to sit with me, and Sherbet will lay down on my headrest. Not uncommon with cats. I mean, we could just store this off in a member variable, but it seems like we should be able to have a constant vector too. Well, it doesn't need to be a vector 2 is the thing. What is it called? I remember the class name for the equivalent of a vector in C#. Just like a XPart object. Like 3 floats kind of thing. But yeah, John, cats can be pretty active. Because I'm guessing that this is treated as a different thing. Tuple, there we go. this case, we just need that. Hey there, Scuff. Well, you've clearly come to the right place. How we do? Why this not constant? Well, clearly, John, the your cat ran into the right place. Oh, well, that makes sense then. If I were doing this, I'm going to have these live somewhere else ultimately, but for now, they're going to live here. I'm trying to think. What? Right, Tess, right. These are going to live in the equivalent of the constants object once we get more of it converted over. The end goal with this is to make it so that as little as possible of the system lives in Godot in the GD script. I may have to have more of it, but so many of our systems already are kind of hollow. So I could just have the GD script on the object be the C# stuff, which should give us a lot of leeway. What's the traditional naming convention pattern for C#? Because I know GDScript likes this underscore pattern. Is that what people use nowadays? Thanks for joining us, John. Yeah, member variables like that, or, I'm sorry, functions and similar like that. But, okay, so this would be like... It's been way too long, man. Wait, isn't it normally like members are lowercase and then like functions are uppercase prefixed? Okay. Okay. Yeah. Okay. Yeah. When this is ultimately implemented, since we're probably going to be using that sort of global object, it won't need to be like capitalized. It'll just be, you know, functions. Give me this. Hey there, Sapphire. And doing okay. I mean, aside from the sleep stuff, been doing okay. Screen size, it is going to be in it. Oh no. Thank you. Oh boy. Embarrassing, but we'll deal. We'll deal. So what we're experiencing right now, Scuff, is, I mean, Scuff, but it's dusting off stuff that I haven't touched for years. I still know the basics of doing the coding, but the particulars of like language syntax has clearly gotten pretty rusty. It's in here just like that for now. Now, if you end up having questions or something like that, like what we're doing at the moment, or anything like that. I mean, Tass has a lot of immediate experience with doing like C# coding and similar. I've done a lot of stuff in various languages. It's something you kind of have to get used to doing. Yeah, kind of like that. Oh, Ember. Hello. Somebody asked if I ever pet the cats, and Ember's up on my right shoulder at the moment. Hey there, Starlet. Welcome. How you doing? So what we're doing here is we've got the basic screen size in place here. It's 1920 by 1080. We're taking half of that, and we're going from -half to +half. We're multiplying by 6 because that's the rendering scale that we're doing. Hey there, Crooked Gamer. Welcome, welcome. Doing an earlier coding stream today. We're starting earlier. Planning on running till the normal end time. Trying to make some progress with the game. Do we have to interact with it? It'll do. Oh, no, still item 1. Actually, take this whole thing. It's something you get used to. Let's see. This is all. We're gonna, for now. So we're working on improving the performance of this. Right now, we can only get to maybe 2,500 objects before it starts to really slow down. Might be able to hit 5,000, but you can see how everything is kind of moving in like short ticks. That's what we're trying to mitigate here. You can really see the slow motion going on here. Oof. Yeah, I know, Emperor. I know. Did I stop petting you? Yeah. Unless she's playing. Ember only trills. Well, aside from purring, as far as vocalization, like loud vocalization, it's a trill. When she's playing, you'd think she was dying. She has this loud, mournful meow when she's playing. So what we're working on is improving the performance of that. And to do that, we are shifting high traffic, high intensity functions here over to C#, which is much better at, busy work. So that's the Godot random. Well, I'll take it if it does this how I want. There's definitely a random somewhere. System. System.random. Right? Nope. That's still a Godot one. Let's not have hash set be a vector 2. Let's... Yep. This seems to have gotten past it. But this one's only returning integers. It would. Bubble that. Bubbles are really overkill for what we're doing. There's a lot of types that I never like to have to use, Parakeet. Yeah, you're right. I don't need decimal values for this. I am going to need decimal values eventually. But if we constrain what we're passing in, yeah. We don't need to worry about it being too big of a value because we should be able to cast a double to a float just fine. Oh, it's a float. And hello, Parakeet. Welcome. Convoluted, but oh, yeah. Thanks, double. Okay. Bring it on. We can do this. Okay. We're going to get a value between 0 and 1, which is okay. And then we are going to subtract half of the screen width from it. Okay. So now we're going to get a fraction of the screen size. Then we are going to subtract so yep. Okay, so what we're doing is we're getting a value between 0 and 1. We're going to get a fraction of the whole. So this will give us something between 0 and 1920. So then we are going to subtract 1920 from that. I'm sorry, half of 1920. So this should get us the range between negative half and positive half. We could encapsulate this kind of thing in a function, but we're not gonna. At least not at the moment. Okay, so each one of these, if we haven't added enough, if we haven't maxed out entities yet, we're adding one. Well, positions. They're just positions for now. See how we can deal with this. Be right back, just a moment. And we're back. I think a random number generation set of tools in a global is going to be in a static, essentially. or at least a singleton, is going to be really useful. Like, just get a random number seed at the start of things and have some methods that you call into to consume it. To each one of these. I'm going to make this public temporarily. Let me go over into the Godot side. I'm going to go into our game scene. I'm going to add a new node. And we're going to attach a script to it, which is so we've attached that script to it. This thing during the physics process should be running. So then we're going to say so then in our process here, we are going to really care about the movement pool right now. Going to add another thing. Then is that add that. Okay. Let's get that error case here. Oh. No, that should be... Yep. It doesn't Doesn't get positions at all. Just set it as a variable. Oh, but we'd have to load it. Yeah, I don't want to instantiate it, I want to get it. I don't want to instantiate it. I want to get that particular one. So I've got it. So I have that, and it should already be instantiated. So this is going to be one of the bigger hurdles, is getting or dealing with this sort of like crossover logic. Okay, so it's not a type thing at all. It is a it is just an access thing. Want to instantiate the nodes, we want to access a node. Because this creates one. Like, that doesn't do me any good. Can I load it then? Nope. How do we access a field on it? String. Good point. No. It does not need to be specially defined. Maybe it's not loading it properly. Lucian shouldn't care about that. What are we missing? Nothing is static at the moment. It didn't matter because it was public already. Because it's not even getting any of the variables here. One of the things they call out is to make sure that the stuff is referenced, or that it is properly part of the project file. But I mean, in theory, it seems like it's it should be building it. Okay, it is being built. It does exist. There, calling into this part of the node. Not our problem then. Because in GDScript, it's just call it directly. But it seems like as far as this is concerned, I need some way to actually load an existing node. Let's see here. Correct, Tess. We're just trying to access a variable. But it doesn't recognize that method is on that object. It doesn't, or at least it doesn't recognize that variable. And based on the test code, if I instantiated that node within the function, then I would have it. But the thing is, I don't want to instantiate a new one. It's being called in process, so it has to be after ready. So we have a public const. Just do a public string just to be sure. Okay. I don't know. Okay. It can't access constants. Isn't that neat? Okay, so it's not accessing positions, but that might be because it doesn't recognize the thing. Okay, so it does not recognize the hash set. Move like. Just gotta learn what will work. We just gotta learn what'll work. What's the method on this? Count. Okay, so it's not recognizing list. If I recall, this worked last time, didn't it? It's not recognizing it this time. Next test here. We can't call anything in we can't call it in Godot because the positions itself isn't recognized. Like, it doesn't recognize that this exists. It recognizes that this exists so we can access it, but this isn't a valid field as far as Godot is concerned, or GD script is concerned. Set up a getter setter on it. Right. Let's try that. Let's start there. Thank you. Doesn't consider that valid. Still not a thing. Okay. Okay. It recognizes a basic array. Ah. Then we ultimately don't have to deal with tuples. So let's try to get positions again. Does it explode? Capitalization. Okay. So as far as it's concerned, this isn't a thing in Godot. Seeing if this is valid, otherwise we'll need to look at anything else. Okay. I'm seeing what kind of functionality we'd have if we just treat it this way. Really don't want it to have to be an array. But ultimately, I don't want to have to pass the array back. We don't want to have to pass the array back. So, how about keep that. Yeah, let's start with just. So we don't want to mess with positions directly. What we want to be able to do, yeah. Let's be crude about this for now. I butchered that one. Oof. Positions dot count. Let's try that. Okay, it's a function that returns an int. Okay. We need to keep the types that we communicate back and forth as simple as possible. Again, I think where we're going to have to be extra careful with this. But I think we can still manage. Four each on this. Or do we have to do one of those screwy create an iterator thingies? We need to iterate over it. We do that. Okay. Something we could do. Oh. Okay. Still work. Some missing closure there, but oh. Okay. Then go in the ready. disable. Yeah. Okay, yep. So we can do that. But all this still, it emphasizes we don't want to do this. Any sort of communication across the gap we don't want to do. So as part of converting the entity manager, we're going to start converting the catalog, movement, entities, positioners, all of this. Yeah, if we have to cross the line, we can. I think that kind of thing is going to as much be, hey, add an entity and then, or get this from an entity kind of thing. But if we keep enough of it away from Godot, then we can limit it to just, here's an object. Oh, man, we can get the visuals in there too. Yeah. And hey there, Richard. Welcome. Let me look at the data here. Yeah, looks like we're getting some latency. Oh yeah, we're getting a lot of latency. Bad network connection. Thank you, and that's a good opportunity. Let's see who we can see. We got 4 out of 5. We can't see Mason, but he might be kind of north of on the bed there. Yeah, it looks like we should be able to do everything that we need to do in C, and it looks like we might have our connection recovering. This is good. Okay, so one of the things that I think we could short term would be the mesh renderer. This guy. Because this is just a node 2D that creates a bunch of stuff. Thank you, Richard. I think, as is tradition. then gotta show off once in a while. Meshes, we have shader materials, we have dictionaries. We are going to need to get... So we need to get the sprite animator in there. So we need to get our shader object. Which means we do need to get a texture in. But we can short circuit a lot of that. We can have an export value for the sprite animator shader. And we can have an export for a temporary texture. Yeah. Okay. Stepping away for just a moment. And we're back. All right. Okay, so this extends a node 2D. So we're going to be able to, I think, get some more tangible results up front by changing the mesh renderer. This will let us update those objects. We can temporarily halt generating any of the actual entities and focus on generating some fake visuals. Yeah. Export, and it needs to be our our shader. Need to be public? Hopefully not. Let's find out. Hello, Sammy. Sammy has come to sit with me. So she gets some back scratches. I'm gonna have to see if I can keep finding more music like this. I do like me some deep strings. Trickier to find. Epidemic Sound doesn't have great categories for it. They have string ensemble, but that's a small pool that they've got for that. Most of mine are from like solo piano. The shader and then excellent. We can use the Godot version of the dictionary. Oh man, we don't really need to though. Again, we're not crossing the line with this, so this needs to be looks like it's going to want to use Godot for that, so this is shader materials and visuals. So that'll have a string and multi-mesh. Yes. All meshes. Okay. So this is the thing that we're going to have a multi-mesh. We're going to have multi-mesh instances that we're going to create as child nodes. The multi-mesh, though, the actual multi-mesh, though, we need to keep that for access purposes. Once we've created the instance, we don't really care much about it. Shader materials. Okay, and then these are the things that will be messing with the individual instance. So are we using this? Okay. So we're using this. This creates the global animation. All sprites of the same kind animate on the same tick. We could randomize this further inside of the shader. Parakeets experimented with that kind of thing, and you can have different variables with them, so randomize the animation, all kinds of good stuff for that. But we will need to deal with different types of animation too, where we'll have to mess with a particular instance's values, but we'll cross that line when we get there. Then we have visuals. This is just going to be positions for now. So we will be able to use tuples in this, but for the time being, let's just stick with vector 2s. Hey there, Andre. Andre, sorry. Hello, welcome. Couldn't decide if I was going to say Andre or Andre. Which is it, Andre? Andre, right? Names, how do you pronounce them? So we have positions. Then in our ready, so this is where we need catalog. What the catalog is going to end up doing is saying like, oh, here are all these textures. So for the time being, we're just going to create the one. So we create a texture, or we set a texture, we set the shaders. So we're not going to iterate over all of them like this. What we're going to do is we're going to create a new mesh instance for that texture. We make a new one. We normally give it a name, or we'll just give it a basic name there. And we'll set its texture. So we need a multi-mesh instance 2D. Go into our ready function. Hello, Sherbet. For those joining us, we are making a game. We are using Godot 4.3 at the moment. And we're in the middle of transitioning as much of the code as we can from GD script over to C#. We're already seeing a big performance boost from testing with it. And given the nature of the Bullet Heaven style game that we're making, we need to squeeze lots of performance out of it. GD script just wasn't doing it. So we create our multi-mesh. We're going to set... We don't need to set its name, but we do need to set its texture. to make a new shader material. Shader. So temporarily, we're going to have a multi-mesh No worries, Copperpot. No worries. We have had a lot of missed broadcasts. That's part of why we're running. We started very early today. Yep. Moving along, making progress. Material mesh. So we won't need to set. Okay. That, and then we are going to create. We're going to set our multi-mesh. Instance count. Big number. That is too many. We should never reach that. Set our multi-mesh instance.multimesh mesh. We would add it to the group. Then we're going to do our quad mesh. Let's see, dot size. Let's use 16 by 16 here. So then we add a child node to it. Then Delta. Okay, so for this, we're going to have a temporary collection of vector 2s here. We need them to be vector 2s to deal with. We could have them just be transforms, actually. No, we'll do vector 2s. Use a crude iteration here. Hey there, Avatar. Welcome. Let's get that randomizer in there. We're going to keep this simple. Okay. Somewhere within the screen is where it's going to create them, or where it's going to draw them. This one. There we go. Hey there, Poland. Joining us for the beginning of the great C sharpening of our project. Positions. Plus. Yeah, and we've also been doing some we've been doing some more offline as well lately. If we were already proficient in a lot of this stuff, we would be moving a lot faster. But it's a learning experience. We're learning as we go. Zero. Rotated. All right, Bullen. Thanks for swinging through. Hey, Half Pint. Welcome, welcome. Half Pint is joining us with a raid on Twitch. I know the feeling of that, Half Pint. Stream is over and they're gone. Screw it. We're just going to do vector 2 right. Figure out how to get degrees to radians set up. Just do vector 2 right. I had my microphone USB cable break on me recently. It was, and it happened like a couple of hours before stream. Much scrambling. So this is we're moving all of the things to the right. This is akin to what we were doing with our test project. Set instant. No, we still need to do a 4. Okay. Should be I 6 0 and then the position. Okay. I'm sorry, Sammy. She's yelling at me as I'm trying to reach over her to get to the keyboard. How dare. Okay, so that'll set the instances. Okay, so then we're going to make one of these in our project here. So we're going to go into the game and we're going to not spawn anything. Well, there's that at least half pint. So go into our game object. Game scene. Hide our mesh renderer. I'm going to add a node 2D. Which will be so. Attach a script to it. There's that guy. So our mesh render now should have build, texture, and shader. Excellent. Shader. Just going to grab this icon as our texture. Well, I've heard that's a good one. Okay, let's... multi-mesh instance as that. It's multi-mesh. Doesn't... Oh. Missed a step. So make a quad mesh. But we don't set mesh is equal to the quad mesh. Try that again. We should have stuff showing up, but we don't. As a multi-mesh, which has a mesh, which has a quad mesh. Texture and shader got... Oh, it got rebuilt. That's why. It's a... No? Hey there, Corn. Welcome. These are not translating over. Double check in the project here. Well, thank you. I appreciate that. Okay. These exist. going to go in here. So we can't debug both at once. There might be a way to do that. I don't know. We may or may not find out. It has a texture. The multi-mesh. Okay, we're not setting the material in the right place. One. Let's scale it at all. Let's That's right, we're setting that somewhere. We were setting that somewhere. We're zooming out here. What else could it be? Is visible. at 0, 0. Okay, I found the problem. You see how we set up a transform here? And then we do nothing with it? Let's fix that zoom back again. Okay, now we've got the instances set. It's being set up to render everything. Texture, it has a mesh. Quad mesh does not have a material set. Shouldn't matter. Yeah, positions. A valid list of variables. Right. Indeed not. We have 3 of them visible on the camera. We've got Sherbet, Mason, and Sky. Sammy is on my lap, and Ember is across from the keyboard. Yeah, okay. It's getting the vector added. Look at our transform. It's kind of interesting there. Thousand instances, we have our mesh. Okay, so vector 0, that array has 0, 0 in it. So if we step over that, and now we look at mesh again. Okay, one of those got set. Okay, we're setting a lot of them. We're not seeing anything. So let's change this. Interesting. In that this is very frustrating sense. Okay, let's. What are we doing in this one? Would be that silly? I kind of hope so, and I kind of hope not, but... setting the scaling to 0, which would make it invisible. Yeah. That's 10,000 things sliding to the side like that. Okay. Now we are going to go in, and we're going to make it slightly more complicated. Hey there, Colin. Welcome. How are you doing, folks? How are we doing? Interesting. Let's see. That's a tricky one. Hello. Let's see. Is that Ludamar? our position is that, so it's going to move slightly to the right. Yeah. Interesting. Should be doing what we want it to do. Iterate over that, then it's going to cycle back around. Not clear what we're missing here. Not clear. Weird. Weird. Now they're all stacked right on top of each other. Break something in the process here. Yeah. This isn't changing. They're all the same. Okay, something wrong here. Oh. Right here. So I was changing the position value each time it came in to a different thing. They were all becoming very small numbers. That should have fixed it. Positions can't be right. New escape start. Okay, bigger numbers. These are all valid numbers. So when do they get mangled? I is 0. So if we look at positions, 394.92. It just got truncated massively. Oh. Right there. Oops. I divided the wrong variable. By dividing the vector, I squished the vector. So it kept getting smaller and smaller. Okay. $20,000. That for now. Semicolon. There is a semicolon. There is a semicolon. What's wrong with this? It's not actually having a problem. Like, it's functioning. It gets built in the Godot run just fine. If I delete that, it just says, hey, wait. There should be a semicolon here. If I delete the line, then it still complains that there's a semicolon missing. Yeah, semicolon expected. Let's close our project here. Took out the entire thing. It's saying I don't have a semicolon, and it's underlining a semicolon. If I remove the line where it says you don't have a semicolon, it points at the start of a blank line and says you're missing a semicolon here. The prior line does have a semicolon. The editor was just flaking out. It's fine now. Okay, so this is with 50,000 entities at 30 physics frames a second. We can get about 24 frames a second. We're in pretty good shape. We're in pretty good shape. We're rolling. We're rolling. Exactly, Tess. Exactly. So we have the basics of the mesh renderer in place now. The basics of the mesh renderer also demonstrate one of the fundamental things we'll be dealing with, and that's calling 10 movement functions. Let's... Okay, let's see here. I think it would be math. Somebody has followed us over on the Twitch side. Hey there, Wild Dragon. Welcome. So Godot has a function for it. The degrees to radians. These are all the Godot objects. Oh, okay. It's GD dot, and we can get like rand f, that kind of thing. That's useful. We do not seem to be able to get degrees to radians. Real quickly here. You're just joining us, Wild Dragon. We are trying to write a game in Godot. We're in the process of translating a bunch of our GD script functions over to C# in order to improve performance. $180. Okay. Seems easy enough. Okay. Just want to see if this works right. All moving. There is no rotation happening. Seem right. Should be what it do. Sub in the value here. Let's also cut down the number since we know we can get really big number. We don't need to choke everything here. Is I always 0? What? This guy wants attention. This guy gets some chin scratches. It is getting rotated. What I'm setting up with this is that everything's being rotated in 1 degree elements, or it should be. But we're seeing no deviation. They're all still effectively moving to the right. So let's add a multiplier in there. Oh. Ah. I create a direction vector here. And it is rotated based on the index of the thing coming in. So it's essentially going to spin that in a circle as we go. I then proceed to not use it. Good times. Kind of hypnotic, isn't it? Wonder if we let's unbind that. Okay, at about 20,000 things, we've got about 55 frames a second-ish. ish. That's 20,000 things. You and the boys would never escape if they were Nintendo games. Okay. So what we've demonstrated so far is we can instantiate all of this stuff. Still think it's wild that Wizards of the Coast actually sent the Pinkertons after somebody. Like, how hard do you have to want to be the villain to do that? So 10. Little hitch at the beginning, that's when they're being created. All right. Now let's look at some things here. What would be the next simplest thing to port? Targeter is actually a pretty complicated object because of how it's put together. The targeter has a series of functions that you swap out instead of trying to create an individual one that would have overlapping utility amongst them. Now, I think we could ultimately simplify targeter, though. There are things we could do for this, but I feel like we would be replicating a lot of functionality. There's some circular dependency going on in this stuff already, though. Targeters store entities. Entities store movement objects which use targeters. So this is the guts of how they end up working. Is we have internal functions for it, and then you call kind of like master functions for them, and they call the internal ones, or they call the set markers, or at least whether they're the defaults or not. And then we have different override options you can set. Which is okay. It does make this it will make this class very cluttered to have all of these effectively like little lambda patterns in here where I just jam the different function on it. But I'm not sure that, again, we can do it cleanly without that. Because I don't want to have a whole bunch of different classes for them if we can avoid it. I also don't want those classes to have overrides that duplicate functionality over and over. So I think this pattern is kind of the way to go with it. Let's look at movement here. Because if we ignore the targeter for now, we just have a couple of things to deal with. Ultimately, we just have this move function that we do. Have to get that targeter in there eventually. For those unaware of the pattern, movement objects are a series of building blocks that determine how an object moves along in space. Then targeters are something that will determine like a particular thing in the world or a particular direction to use. So you might have something that targets the player, and we've written code that does things like circle that target. And that's kind of where we want to get to. But again, targeter is so complicated to start with. So let's start with movement, and we'll get there. So you see, I chose object. This is Godot object. Even if they don't inherit something, I think they intrinsically inherit Godot object. I think so. This should be the lightest weight thing they can inherit anyway. Okay. So one of the thoughts with this is an opportunity to do some revision. It's right now, movement objects take that entity and they will assert changes to it. Right now, they're setting a target movement on it. They don't really need to set that target movement, but I think we should maintain that. Okay. So we have just going to have delta here. We're having it be a variant for now, because we don't have that defined just yet. I'm making some shell functions so that we can get the workflow in place. In the move function, we're going to call our internal move here. Now, the reason we do this is there will be parts of the workflow, like right here. We move and we clear modifiers. This is to make it so that there is something that always happens when you move. And then when I override it, this is the logic of the movement. This clear modifiers is meant to deal with things like the speed or the scale of it being adjusted. So during a particular pass of it, when we do that movement, we're going to need to change this, but we will apply modifiers. So it might be, hey, subsequent ones pass this speed adjustment down. So we need to figure out how to do that again. But right now, we're just going to stick with this pattern of there is a public one that gets called, and there's a private one that's going to get overridden by the child classes. Okay, so we just have our move function for now. It will eventually use a targeter, but whatever. So then we're also going to have an entity. The entity has a great deal of footwork going on in it. And some of this is going to stay relevant, some of it won't. Because some of these factors are things that I'd like to start splintering off into other logic. Like once the entity has been created, it doesn't care about its physics, shapes, or its visuals anymore. It doesn't need to care, because we could just have it send an event or trigger an event that says, hey, my position is updated to this. My position and facing are updated to this. My animation is updated to this. So that the corresponding objects, these visual objects and whatnot, get those updates without us having to keep references to them. So we could have things like, hey, subscribe to this entity or something like that, but we'll see. We'll see. We also have the concept of a spawn point. be a good one to get rolling too. We later discovered that this isn't really necessary. We can just say new here. Why did I need updated position? Okay. So a spawn point is entirely logic set up for this. Get spawn position. I can foresee some logic changes down the road that will need more data than they currently have. So spawn position relies on things like some global concepts, some kind of master controller kind of things for the game world. So like the spawn position that kind of hides just off screen, or kind of a rotating spawn point. Where the player is, those kind of things. But having something like spawning on a source entity. For example, if I have a projectile that says, oh, I explode on impact, that explosion would be an entity that appears for a short period of time. Or similar. So I would want to be able to say, hey, spawn at this point. But similarly, it could be spawn on some other entity, you know? So having a way to set that when we come in, that would be useful. We'll get to spawn point. There's some thinking I want to do on that pattern again. For now, we'll just set up. We need to be able to move the entities. So we need the concept of an entity, and we need the concept of a movement object. For the time being, let's think here. We are going to have Vector 2 position. Let's make it a property, can't we? But yeah, it's making it a property. I can foresee us Hey there, Isaac. Sure. Been a little bit since we showed the cat cam. Let's see, we have Sky and Ember snuggled up. Oh, we got all five. So Sky and Ember are snuggled there. We have Sherbet and Mason left to right on the bed. And then Sammy over on the shelf. Stretch from Sky and stretch from Ember. Hello, Sky. It's got that big ol' yawn from Sky there. Yeah, hey. Okay. Syntax. So it has a position, and then position. Make 10 of them. This is just building upon the pattern that we already have. We're making an entity object that has a position and it has a collection of movements. Right now we have kind of the arbitrary limit of 10 of them. I think that's a reasonable maximum. Where we'll fall, we'll have to see. We're just kind of layering on the functionality here. One little bit at a time. Okay, we iterate over it. Zero. Okay, so this is true. This is, kind of a shortcut here. We're just setting it up to where every entity that gets created has these. So mesh renderer, we're going to have to get the entities from somehow. But really, we don't want the entities. What we want is position information for them. Think on that a little bit more in a moment. Be right back. And we're back. So if instead did I have the be right back on? Or did you just mean you stepped away? Okay, so if instead of positions, we have a list of entities. Ah, okay. Okay, so now we've got the concept of entity. Let's position. Hmm. We're spinning on something. And we're going to get rid of you for now. Hmm. Never getting out of this. What? Oh. Hey. At the very least, we should get back here. Okay, clearly I did something wrong here. This is our loop. Oops. Super loop. Okay. Nothing was getting rendered there, so let's look. Very strange. Let's look at. Oh, same problem we had earlier, or yeah, a little bit earlier. Let me show you. In this, we create an entity, and we set its position, and then we do nothing with it. Entities. Add. It helps if you want to iterate over the collection of things you made if you put it in the collection of things you've made. You know. I've been tempted to do something like this. With the logic of this is that each movement that's added doesn't make it faster. It just becomes part of it, you know? The capitalization matters. In the case of C#, it still seems to want it to be the exact casing that it is regularly. Now, I wonder if there's an alternate that C# uses that is its context, but it's the same thing, you know? Okay, so we have entities. The entities have collections of movement. Still works. That is rendering it 60 frames a second with 10,000 entities moving 10 times each physics tick. $20,000, there is that initial lurch. We can hit about 55 frames a second with 20,000. So we're well within acceptable range. Yeah, aside from the load up, we're set. Okay. So one of the next things that we need to start doing is setting up the ability for these things to talk to each other. Because we're going to need the idea of the global entities. But I wonder if we can dodge some of the... Because it's not really a global that we're dealing with. There is essentially a group of things that need to speak with each other. They need to be loaded in a particular order. But their existence is dependent on the game world. So as far as the objects that we've had, the idea of some global functions, that's fine, like a static class that contains some functions. The catalog is another one. There needs to be a catalog that everything can reference. And that can be preloaded. That can be loaded at the beginning of the program. That is the thing that defines all of the things in the world. So if I want a player object, that's the thing that defines it. Or we can ask for a player and we can get what that says a player is. You know, what it looks like, how it moves, that kind of stuff. The reason that we're having to remake a lot of stuff is that we're avoiding the crossover between C# and Godot. I want as much of the guts of the game to live in C#. So the catalog is effectively a singleton. Whenever we interact with it, we're interacting with the catalog. catalog, what does it need out of it? Why does the catalog have a scene? Okay, at some point the catalog had some things that it needed as far as imports, well, exports. That's another thing I want to avoid, so we shall. So as far as images, we have those defined as constants. We have a whole bunch of dictionaries. Create that. So when we get one of these, we just pop the item from the catalog. And the idea is that that thing could subsequently just be used to stamp out copies. We'll have some other functions that we can work with on that. But the big things for this is getting it set up so that we can load it, and then having each of the individual objects have its apply template, where it essentially copies like this creates a copy of it kind of thing. So that is a instance ready to use when we do that. Okay. Just going to start with object here. We'll figure it out after. Because I'm not confident that, like, I don't want to re-access the object, so I don't want to re-instantiate a catalog. So I don't want it to be a node out in Godot space. All of these need to be things that can talk to each other without touching Godot space. Quickly do a quick commit. We've been at it for a few hours now. quick little commit in there. We have the luxury to mitigate some of this stuff. We don't want to store off things like actual textures unless we need them. We can just use strings and say, this is its identifier, you know? If you actually need the texture, go get it. That way, the entities aren't carrying around more expensive objects or references to. Icons are essentially textures. Yeah. So for the purposes of, we don't really want these things, anything actually reaching out and touching these collections. So we'll have a special function for getting all of the keys of the textures. Yeah. Add something in here. Using, okay. Come on. Does that work? Oh. Oh. Yeah, it looks like this will get us through as far as what we need to do. We're avoiding using as many of the Godot classes as we can unless we need to. So, like, texture 2D is what Godot views a texture as. So we're going to use that because we need to stuff that into things like the multi-mesh. We're only going to use this really once, so... we give it the list, then we can have it go in and we can have it retrieve the textures. Okay. This is almost entirely for the purposes of the mesh manager setting itself up. Every texture that we load in this case, it will create a multi-mesh for. Now, we might be able to get away with some shader shenanigans where we, for each visual, we say, oh, you load this texture in as a shader variable, but I don't know if that'll actually make it more or less efficient or not. So for the time being, we're going to go with lots of multi-meshes. Textures. So doing this makes it so that we know we get this texture, and then we can get the dimensions of the texture and whether this should be rotated or not when it's rendered. Effectively, Parakeet, it would be, let's say I have, like, right now I have blobs, mice, and the player, and technically, like, the yarn ball. Each one of those textures gets a multi-mesh. There's weaknesses to that. Because it creates an intrinsic sprite ordering, but there are probably ways around that we can figure out. Because we'd want to have some of them have precedence over the others. Like, the player should have high precedence so the player never gets lost in the, in the screen clutter. For the most part, I think it would be, players, projectiles, and then monsters. Ultimately, I would want all of them to render together as far as Y order or Z order. So that may be why we try to fiddle with the way the shaders work and set each instance of the shader to have the corresponding texture from the catalog. But we'll see. For now, we're doing the one multi-mesh for everything, and they are more or less in the order that they appear in the catalog. Let's get some of those constants in here. Just copy paste them, it'll pitch a fit, but item icon terrain player PNG. So sadly, this is one of the things that we actually need to have like text path to. But that's why I'm defining these static constants, So if we mess with stuff, we have a place to go to change it. Not ideal, but we can deal with it. Okay. Go to textures. Part of why we're doing textures first is that we can figure out how to get this catalog communicating with everything else. May need to create another object here to cover this. Just bang it is. Hey, explicit does not. Okay, so each of them has some constants here. These will be public statics here. Constants. Yeah. So in this scenario, Parakeet, there would be 4 multi-meshes that are set up. there was syntax for. There we go. Contain it. I think we need the texture wrapper here. Because we do have additional kind of metadata about the texture that is going to be used in like animating it. Yeah. So the texture 2D, the overall size of it, the frame size, and whether we rotate to face or not. This is ultimately a struct. Can I get away with that? The texture wrapper is just an individual entry. It won't be interacting with GDScript. The only things that will interact with GDScript, what I'm hoping, will just be the nodes containing things. Please don't interact. This should be a vector too. Yeah, because this is the size of the both of the frame. Oh, sorry, the frame size. Texture size can just be a tuple. Yeah, they're both integers. They're both. only use the Godot ones when we need to directly pass it in. Should work. We're going to be just going to have one of these. All of these. So. So we load the texture, we set our frame size, then texture size based on the texture, then the rotate to face, then we add it to the collection, the dictionary. That. Doesn't scan though. Right? So might as well be a vector 2 if we're going to deal with it that way. Frame size is new vector 2. All right, and that's the pattern for loading into our textures. Okay. So the last thing should have precedence because it's the last one, and if it's the last one in the tree list, then it should have precedence, which lines up. So this is where we might run into an issue with the way that we're returning the keys. Or just the way that we're storing this in general. Having an order is kind of important here. But we'll see how it plays out. We'll see how this plays out. Blob. Turn ball. Player texture. So now we actually want to create multiple of these. So we get the multi-mesh here. Hello, Zane. Welcome. Guy is always kind of hesitant, or doesn't frequently come to sit with me, but he will now and again. He demands much attention when he does. Singleton. Should be able to say catalog. Hey there, Laura. Welcome. Find some kitties. Sammy passing through. Sharpening her claws a little bit there. Ember is creeping up on her. Look at that. Sammy looked, Ember sits down. You didn't see nothing. We are working on a Bullet Heaven style game. At the moment, we're working on converting all of our GD script stuff as much as possible over to C# because it's helping with the performance. Okay, so create a new multi-mesh. Texture is equal to wrapper. So a lot of my what I say here is responding to people, answering questions, that kind of thing, some light chat, and a lot of coding stream of consciousness. So don't worry about interrupting me. I'm happy to talk. This makes me want it to be a class now. It'll make it nullable. This gives us a solid error case. It can be null. Give it a bad key, you will get nothing back, as opposed to you will get a struct that won't contain universally accurate data. Amber. She's on the catwalk above me. Fail safe here. Well, no. If we got a key, no, we should be safe here. Got frame size. Let's look back here. Setting up the mesh renderer. Shader material, we set the parameters here. Okay. String and value. right. So the mesh renderer doesn't need texture anymore because it can get it. Still needs the shader. And we'll need to mesh and material are individual things that we need to add in. Guns. Oh, spelling. Wrapper. Dot. Size. Frame size. Okay, this is true because frame size is universal across the texture. So if it's a 16 by 16 frame size and the texture is 32 tall, there are 2 animations. And by default, we always say use the first animation. So even if the subsequent, if it subsequently isn't changed, then we'll still keep the 0. So that covers things that never change their animation and things that only have the 1 animation. So somebody moved in a slightly sudden fashion. A jolt to my feet. Yeah. having to type around Sky at the moment. Make up your mind, sir. Guy needs a hug. Yeah. So then the entity will need a texture key. It doesn't need the actual texture. It just needs the key because then we can get the mesh. Position needs a get set because especially when there is a set, we're going to need to do some other stuff. If you change the position, then it will need to broadcast out. There will be like a set position function. Can't really avoid. For now, it's going to be a public string. This is a multi-mesh. Meshes. I so that we don't have to keep trying to get it from the collection. That's cheaper this way. Okay. Say to the log dot blob. Hey, does it explode? I mean, it doesn't work. That's true. It didn't crash, so we've got that at least. Okay, let's run it. Let's run it through Godot side. That's the regular one, but this one isn't getting anything. Which is because the catalog is never being instantiated. Just be static. Thought I heard something. Okay, we're never instantiating the object. We can still call these methods because they're statics, but all of them have fail-safes in them. Like, we get nothing back because that key doesn't exist. Okay. So the catalog needs to come into existence at some point. In order to get load textures to happen. Now we could accomplish this with a global Godot node. And load this as a... Yeah, catalog above all of the others. So we'll have to make it a node. Okay, short term. If I remove that one, it's going to pitch a fit. Get it back in eventually. 1 second. need to have the original catalog in place for the time being, so all the way up at the top using this incredibly... There we go. Constants first. We are going to temporarily change the name of this thing to be CS catalog. Problem is, the existing Godot code uses this extensively, so it doesn't like it when it does not like it that the Godot requires that anytime we load a CS file that it be named the same thing. So the core class has to be named the same thing as the file we're loading. So we need to rename this file here. There. Okay. Not compiling. Where is the error then? So now if we look in this, I want to know if this will actually catch it. It does. Means we should hop along through this. That'll be a problem. We need to instantiate these. Okay. We're not getting the texture there. Make sure that our string manipulation is coming through correctly. Maybe I need to restructure it here. That is correct. Oh, it got it there. On the wind up. Oh. Not on enemy path. Item path. Do. We're getting there. Okay. Okay, we have wrapper stuff set up. Okay. Well, it should be working. Create a bunch of them. We set their texture key equal to the target here. It's a thing. Yep. You're 91. Yeah. Yeah. We're adding them. Getting past that. Oh. These are never being nude. How that was not airing earlier in the process, I'm not certain. That's not working quite right. Not working quite right, but we're getting there. Let's just load one. Okay, it's not slicing up the object correctly. Go into our game scene. At our mesh renderer. It's got the shader. And animations. go into loading the mesh renderer. Yeah, it's much more emphatic and you get nastier errors. Shader. Let's do up and down and a basic 6. So there's 2 animations with this one. And we're setting the animation to 0. Set the material on the quad mesh. Actually, where we need to set it, though? It's the mesh instance. That's right. Here. Look at him go. Boing, boing, boing. Ha Blob loaf. All right, we've got the animation going. Their facing is not being edited because I don't have the logic where it changes the movement in it. But that's not terribly difficult. What it will require, though, is that now we need to start looking at the interaction between the entity manager and the catalog in the mesh renderer. So right now we've got this little hack here that says, hey, I control the number of entities. I'm just going to stuff this collection. But this thing should not be talking to entities, and it should not be generating them. So we need to add more to the catalog. We need to add like the movement creation to the catalog. We just need to start adding more of the things. Targeting is one that we need to get in there if we're going to get the movement down. targeters are kind of complicated because they do a lot of... They effectively use like swappable functions. So we're saying, hey, this method is actually equal to this kind of thing. So we're invoking methods, you know? I'll have to look into how to do that in C#. But I think we've got some pretty daunting ones heading up. Ultimately, what we are doing right... Yeah, there you go. Here, let me show you what we're doing. Targeter. So, got it. All of these, we default them to a couple of functions, but part of the construction of a targeter is setting these to more particular ones. So, you know, do I need to update it? This is entity dependent. So if I don't have an entity or a direction, then I need to update the direction, that kind of thing. But by default, need to update direction just says if I don't have direction, if it's 0, 0, then I need to update the direction. Some of these are pretty flaky, and it's a good opportunity for us to change them. But we go in and say, okay, set it to this function sort of behavior. Which is fine. We do this so that we don't need to have as many flavors of the same thing. I don't want to make a whole bunch of classes and then have them overlap with these methods. Like, we can do interfaces with C. That's nice. So we will have that opportunity when we're rebuilding stuff. Done downloading, or you're done playing it? Well, here's hoping it was worth the effort. So we would be setting up a bunch of these methods with the goal of configuring the targeter to use particular ones. So we'll need to recreate this kind of mess here. Need to figure out how to get that wrangled. For those not familiar with the whole infrastructure, you have entities which are, things in the world. Each of these blobs is an entity. Every bullet is an entity. Entities move around following the combined movement logic that they have. So in our... use this one. So currently in this, we are creating a bunch of entities. And those entities by default currently are populating themselves with 10 movement objects. And the only thing those movement objects currently do is move it to the right. We can do other stuff here. So we could say... position here. At the moment, movements use child classes to change how they work, because each movement stores off different variables and the like. So I'm going to add a private vector2 direction. Direction to new 2. And that new vector2 will use d.and dot rand. So we set the direction, and instead of vector2 right, we use direction here. Now, this will create very weird motion, because each of those 10 movement objects is going to fight with the other ones. This is 15,000 slimes moving in a very randomized direction. It is not impeding our frames per second. We are still getting right about 60 frames a second, which is excellent. We don't need 60. Behold the jiggly chaos. So if you watch, some of them are hardly moving at all, because all of the different movement objects they have vectors that are conflicting. We get why sort enabled didn't work there. Is there another place that it could work? No, this is just, I think, a Node 2D thing. I think this would work. Not the end of the world. Okay, quick break. Be right back. And we're back. And if you're still there, thanks for joining us, Half Pint. So, thinking on it a little bit, the mesh manager as it stands has trouble being global because that means it sits on top of everything else. It becomes a high level object, let's say. We look, so let's run it. Let me go over here. In Godot, auto loads are top level. They're right above root, and then your first scene appears. So if the multi-mesh is up here, that means it sits on top of everything else. And I don't really want that. So we could have a communication layer in between them. Because thinking on it, I don't really need to have the translation objects anymore. The translation objects of the entity just saying, here is my position, to the collision logic, I don't need to separate that. because the only reason I needed to separate it was because we were frantically clawing at more and more performance gains. And it wasn't working. So we could just have the entities be available. We can just say, hey, for all the entities that exist, I will loop over it during processing because I'm the mesh manager. That means the entity collection would need to, the entity manager needs to be a high level thing. It doesn't need to update physics at all the time, but it can. I mean, it can iterate over a collection of nothing all at once. So if we make the entity manager a global entity, then the mesh manager would just need to talk to it. The mesh renderer would just need to talk to it and get the collection of entities to iterate over. Yeah. We would need to... Everything that should be happening in the main thread should be thread safe. We should never have multiple physics entities working at once. So it should be okay. Well, come on. Are you going to sit with me or not, Sammy? It says, I'm not sure. I'm just going to stand halfway on top of you and decide later. She's being real loud today. She's also being very needy, so you can see that she kicked the mouse there. Okay. What are we gonna do? What are we gonna do? Alright, if I turn... Where did we put it? If we make this into a constant thing, a static thing, that should still be read-only. There we go. Okay, so this thing is a singleton now. mesh render, we'd go into our config up here. So every frame, we're going to add 10 of them under this pattern. Don't want anything messing with it, but for the time being, do that. Then in the so we're gonna need to set we're gonna need to make this a this needs to be a global node so that this that We want to be able to cleanly add or remove from it, but we also need to be able to iterate over it. So let's see here. We're trying to figure out how to iterate over the entire hash set here. Oh, but I need an index. I need an index. We can do that. Yeah. Okay. So we get the current entity. Let's see. King. Ah, okay, okay. Little bit of a wrinkle here is that there are multiple meshes to deal with. So any entity in the list could potentially be in a different mesh. So we need to pre-process it so that for each For each mesh, we are keeping track of how many entities we've iterated over. But what we really want to do is parse each entity into its own bucket. And then iterate over those buckets. Okay. Have a string, and then it will be a list entity. Okay, so what we're going to do is we're going to loop over the collection of entities in the entity manager. We're going to break those into different groups. We're going to add them into buckets here. So we're going to create new lists to exist for every one of the multi-meshes we have. So the keys in the dictionary here. String key in meshes keys. And longer term, what I want to do is have a way to communicate between them that when we add an entity, we can call out to any other object that cares, and it can get the entity list, and that thing can subsequently listen to this entity is going away. So we could have two different events on the entity manager that calls out when it's adding one and when it's removing one. There's still some wrinkles in that we would need to work out first. Okay, so we add a list for every key. Now we have a dictionary of lists that we can add all of the entities, that we can break the entities apart into. So we don't want to iterate over the entities if there's nothing there. Come on now. Okay, so if we have entities, going to actually move this outside of that. Get that out of the way. So we're going to, it's if there are entities. This up here. Okay, so we prime a bunch of lists to contain entities. If there aren't entities in the list, these are going to be empty. It's relevant that these are empty because once we get here, for each list of entity list in lists, then inside of this one, we are going to say mesh to oh wait. E in entity list.ease. Okay, we're doing that because we're going to need that key. Lists. So we get our list of entities. Mesh is equal to meshes mesh.visible instance count is equal to entity list count. This is the critical part, is I need to have these lists because if there's nothing in it, since the last visual update, this makes all the stuff go away. Then entity list count plus. Entity list I Okay. Now we need to figure out how we want to do this enumerable thing. I don't actually need to enumerate this way, do I? I think it's important that we do. Looks like we're supposed to do... Feels like we're supposed to do this. Way. Check here. Okay. So I'll move next. We get the current one. But we're not going to be doing this. We are going to say... this... add... entity. Push that a little bit more. Nope. Okay. This is kludgier than I'd like, but we'll get there. The entity. Move. So. Need a script. What for? So now we go over to you. And we're going to manager.cs. Already have that. Okay, well. Need to get to a point where we can gut some of that, but for the time being. All right. Got that. And now we can go in and we can add that one. It's named correctly. Just get that out of the way. Okay. Work, right? Yeah. That's working. Might be hard to tell, but they are popping into existence currently. Nice. And one more time. Oh, okay, yeah. So, one of the things we need to do is we need to make sure that we are shutting down the entity manager at the end of the game loop so that when we run like this, so if I start this and then exit it and come back in, then the entities won't have gone away. Just so. Look at them go. All right, so we're going to need to make sure that the entity manager is obeying the game tick. So I'll probably have it be that the entity manager is told that it can go. Essentially like a call deferred physics tick on it. We'll see how that works. But I think that's a good place to stop tonight. We made a lot of progress, a whole lot of progress. This is serving both to aid in our performance efforts. We want to get those 10,000+ things on screen at once. But it's also giving us an opportunity to essentially rip up the floorboards. We've had to do that before, and we're doing it again in order to make the game operate as cleanly as possible. But it's just getting to go in and revisit, like reconstruct some of these classes is helping us. We're going to be able to clean up a lot of the stuff that kind of accreted over time. But I do hope everybody had a good time watching with us tonight. Even if you don't understand coding, I hope you learned something, or at least had a good time listening. With that said, if you like what you saw and would like to see more, remember to like, follow, subscribe, all of that good stuff. It helps the channel grow, and it will help you find similar content again in the future. I hope you have a good rest of your day, and I'll see you next time.